Edexcel Mechanics 1, Work Energy Power 1, Work and Energy. Work. We could define work in the following way. Work is done when a force is applied to an object and the object is moved through a distance by that force. It is a scalar quantity that is defined as follows. The work done by a constant force equals the force times the distance moved in the direction of the force or a component of that force if needed. The SI unit of work is the Newton meter or the joule. Although work is a scalar quantity, a force may be positive or negative, so the work can be positive or negative. It is possible to calculate the work done by a variable force, but here we will assume that all forces are constant for now. This is a similar analogy to temperature. Temperature, although it's a scalar quantity, can be both positive or negative. And it's a similar concept with work. If there is no movement, then no work is done. So at this particular instant in time, the weightlifter is not doing any work as the weights are not actually moving. So although no work is being done, obviously there's a lot of strain and force acting on the muscles in the bodybuilder's arms and legs, but no work is being done by those forces. So for example, if we have a sledge and this is being pulled horizontally along a smooth ice by a constant horizontal force of 45 newtons, if the sledge moves 10 meters, how much work has the 45 newton force done? We know that the work done equals force times distance moved. So in this case, the work done by this force is 45 newtons and it has acted over a distance of 10 meters. So that's 450 joules of work done by the force. So what happens if the rope is at an angle to the horizontal? So for example, the sledge is now pulled by a light rope at 50 degrees to the horizontal. If the tension in the rope is still 45 newtons and the sledge again moves a distance of 10 meters, how much work is done by the force now? So there's a diagram showing the situation. How much force is done by that 45 newton force when the sledge moves 10 meters forward? Here the direction of motion of the sledge is obviously horizontal. However, the line of action of the force is not. Therefore, we need to resolve the force horizontally to find the work done by the force. So here we'd be interested in the horizontal component of that force. So if we imagined a little right angle triangle and looking for this adjacent side, we'd be using cos 50. So I think that component is 45 cos 50 degrees. And there we can see it. So we've got a component of 45 cos 50 degrees newtons acting over a distance of 10 meters. Therefore the work done by this force is 45 cos 50 times 10. That's 289 joules. It's worth noting that the vertical component, 45 sine 50, because it's perpendicular to the line of action, has done no work. It's only 45 cos 50 that has done the work. In the next session we're going to be looking at kinetic energy.